architect himself, his experience and accomplishments within different scope topics. So now I would like to ask Mr. Filippo to give a brief bio about himself before the lecture begins. And we will have some time before the end of the lecture for some Q&As. So may please go ahead, sir.
Thank you, Nazik, and thank you everyone for the kind invitation and welcome. I'm quite happy to be here. Just to tell you a bit about myself, I graduated in 2010 in Italy, and then I started working on research projects and product design products there. I founded my own research group in 2012. This is named MOX, and we began as a European-funded project working on mass customization system for product design, generative design, and 3D printing. So we were basically thinking how to evolve product design in the light of new technologies and methods. I'm going to go pretty much into the details during the presentation. Then in 2015, I relocated to London, started working at ZAHA HADID Architects, first as part of the Computation and Design group, and then as part of ZAHA HADID Design, where I work on small-scale projects and art installation and experimental structures. On top of that, I teach at UCL Bartlett in London. And yeah, I've been lecturing a bit around and doing a few independent exhibitions. And I guess as an overview, these 3 chapters kind of summarize it all. You're muted.
Sorry. Okay, so you will begin the lecture now, and then we have questions for you at the end, including about your bio also.
Absolutely. Perfect. So I'm going to begin by sharing a presentation, so we all can get a few visuals for that. Oh, sorry, I need to redo it and share the sounds also. There will be a couple of videos in there. I hope you can see full screen the first page, post-natural design. So the starting point of this presentation, in which I'm going to highlight many projects from the 3 frameworks in which I've been working in the last 10 years. The starting point is the idea of post-natural. So post-natural, it's something which I define that can be described as an ambiguity within contemporary notions of natural, artificial, human, not human, technological, cultural, digital, and material. So meaning we tend to always think as this thing as something which are oppositions, like natural versus the artificial, human versus technological, cultural versus technological again, or digital against material. But I do believe that in contemporaneity, there are more and more phenomena and things that we can observe that are actually saying that these distinctions are not that neat, are not that sharp, but actually things are much more hybrid and complex and mixed between these. And I do believe that the new direction is also something that can give ideas for how to create new visual languages and new directions for design. So getting a bit more into the details of that, I will begin by giving an overview of philosophical thinking and observations from the world around us. Let's begin with a quote from Steven Shaviro. We can no longer think of nature as one side of a binary opposition. In an age of anthropogenic global warming and genetically modified organisms, not to mention big data and world-encompassing computing and communication networks, it makes no sense to oppose nature to culture, or a state of nature to human society, or the natural to the artificial. Human beings and their productions are not separate from nature, they are just as much or as little natural as everything else. If this is something pretty much theoretical, let's start observing some of the things which are happening in the world around us. So these are images from a photographer whose name is Edward Bortinsky, whose work is focusing on the impact of the human action onto the world, onto the shape of the world, onto the appearance of the world. So whether they are images of like terracing for growing rice in Asia, or patterns created by pollution of liquids onto sand, or the image on top left is like a layering of car paint in Detroit. What strikes me about when I look at these images, this is something pretty much coming from man, coming from the human, but which has something very natural into that. So the way in which the world is being shaped by the anthropic action, by the action of people, is actually something that tends to resemble more and more natural pattern, like all this detail, all this articulation of shape and forms is something which looks at the same time very natural. So maybe when you look at these images, you start wondering that probably natural and artificial are not things which are distinct, but actually there are spaces in which the two things tend to merge or become hybrid or more complex and not be resolved as oppositions. That's something that we can also see in our own production of cultural elements and softwares to create new realities. If you look at the three models on top, two are physical ones, real women, and one is completely digital. And I guess it's not that easy to catch which one is the digital one and which one are the real ones. So what is interesting for me in this image is the fact that traditional categories such as physical and digital may become at some point more and more complex to distinguish. So we can have something which is digital, which has an appearance of extreme physicality, and the other way around as well. So that's something that we all can also see at a more abstract level in the image at bottom. This is basically a particle simulation done in a visual effects software. And what is interesting is this appearance of strong materiality. So if you look at that, you think of something really physical, material-like. You want to touch it. You feel that there is something very related to the materiality of things into that, but the image is completely digital. So if we talk about visual languages or the production of design outputs, this distinction between something that is digital and something that is physical is becoming more and more complex and blurred and ambiguous. And that's something which has been quite a lot there in science fiction and the production of movies as well. These are screenshots from The Matrix, which I'm sure most of you have seen, or I suggest you do if you haven't. And there is already the idea of like the character being able to access a digital reality, a virtual space into which they actually do have physical inputs, and it's becoming quite complex to distinguish the two. So even if you are in a virtual environment, yet the information you receive is pretty physical, and maybe these layers are not that distinct as we tend to think. At another level, this is another movie from David Cronenberg, and it's named Existence. And the idea is that there is a virtual reality game which you access by plugging onto your spine that kind of pod. And so basically, the pod is a technological element. It's a tool that allows you to enter a digital space. But if you think generally of the appearance of the digital tools that we use nowadays, they're mainly made of metal or plastic and glass. It's very modern, it's very transparent. The range of material is something very abstract in a way, very modernist. But what fascinates me in these images is the fact that technologies can be actually be something completely different, can be biological in the way it looks. So maybe the computer and the laptop is not the only way to access a virtual reality, or the smartphone, but maybe there can be something else very organic with a completely different code of behavior, like objects that can feel emotions and get sick also, and transform in time, age, and all the properties that we generally associate to living beings can actually be transferred to technology as well. So maybe also the distinction between technological and biological, or technological and natural, maybe it's another one that can be challenged and discussed in a different light. And that's something at the basis of much of science fiction, from Blade Runner here to Ghost in the Shell, even to the point, I don't know if you've ever seen the anime of Ghost in the Shell, there is this scene at the end in which the character is fighting against the machine, and there is this ray of shots onto the wall, and it's like portraying this tree of life in which at the top there is man, but this tree of life is covered by these gunshots more and more. So in the end, it's like criticizing the whole structure or who's on top in this tree of life, whether it's technology to be the next one to come. So in the words of Donna Haraway, I want to signal three crucial boundary breakdowns. By the late 20th century, the boundary between human and animal is thoroughly breached. The last beachheads of uniqueness have been polluted, if not turned into amusement parks. Language, tool use, social behavior, mental events, nothing really convincingly settles the separation of human and animal. The second leaky distinction is between animal-human, organism, and machine. Late 20th century machines have made thoroughly ambiguous the difference between natural and artificial, mind and body, self-developing and externally designed, and many other distinctions that used to apply to organisms and machines. Our machines are disturbingly lively, and we ourselves frighteningly inert. The third distinction is a subset of the second. The boundary between physical and non-physical is very imprecise for us. So if this is portraying, it's a number of things that you look at in the world. And I mean, I guess each of us as designer has its own, the thing that makes you click or catch your attention and make you think, oh, maybe that's a direction for design to go, or something which I can research upon, something which I can get something new. What I just presented was the set of references that we had in the back of our minds when we started working with MOX. So at MOX, we began in 2012, sorry, as a European funded research group and startup. We were working on products which were customized onto the human body. And our research actually is being characterized pretty much by these masks, which we've been doing a few. Actually, our first project was a set of masks. And for us, these masks are speculative artifacts, radical objects. They always help to start focusing ideas and to discuss at the same time these very larger questions, such as how is the human body going to evolve, how the relationship between man and technology is going to evolve in time and shape new forms for our bodies, how our body is going to transform, but at the same time also to focus many technical aspects of design. So how can you design objects which are fitting perfectly onto the shape of the body? How can you control, orchestrate, and generate this type of very complex biological looking patterns, and so on and so on. So I'm going to get into the details now of these projects. And the first one is a set of masks, the collagene masks, and I let the video to talk a bit about it. So the inspiration of this project are fibrous formation, which is something which I believe is also very architectural reference. So the images that you're seeing were shot in a temple in Cambodia. Is actually a set of temples where you can see what is very characteristic is the relationship between the built architecture and the biological formation. So architecture, in this case, the temple becomes a substrate for the growth of the fibrous trees on top of that. And this relationship is articulated at many scales. So there are branches with changing size, changing resolution. Certain branches are larger and other branches are smaller. And it's incredibly fascinating reference. I think visually is so rich that there are so many things, like it's not only about the pattern, but also the way in which the larger branches become almost like muscles, embracing the object. That we were incredibly fascinated by that, and we felt there was a potential to explore in design. So the key idea of the workflow was to put together a 3 stages workflow, in which the first stage is the 3D scan of the people that will become the users of the mask. Then a set of tools and a digital simulation of fibrous formation to actually design and put together the actual mask. And then everything needed to stream directly into 3D printing the products and fabricate them seamlessly. So our process in terms of the fibrous formation was handled through a software that we wrote on our own. It's a piece of generative design it was done in processing back then. So the idea is that there are a set of curves, which are the ones which are being traced eventually onto the face of the people. And a population of secondary curves are being created, what you see at top right, starting from those hand-drawn curves, then rearranged through a bounding algorithm, and then eventually turn into a 3D object ready for print, which is the mesh that you can see at bottom right. So this software is allowing you to automatize the modeling, and that means that you can create a number of variations in a very quick way, and that's fundamental for the success of this project. So the idea is that you just create a vast pool of possible objects, and then you select the ones that work better. Different people yield different objects, support different objects. So the shape of the face is different, but also the design choices are different. So for every person, you get a very different mask. What fascinates us in terms of design when we were looking at these objects and thinking what they can be is the type of relationship between formation and body, pattern and body. So I think that this collection of masks is detailing pretty clearly an idea of symbiosis, like there is a relationship of symbiosis between the mask and the body. So and then the other masks, which we're going to see in a second, will detail different kind of relationship, but this is something that stands out. Just as a reminder, as I was saying at the beginning, the idea is always to try to think of an evolution of the human body in relationship with technology, how technology can look in the future, can be transformed. And our take on that was to think of technology as something between biology and artificial reference, a post-natural object as in this kind, and that embraces a relationship of symbiosis with the body. I'm saying that the object is post-natural because when you look at it, it becomes a bit hard to say whether this is a natural object or an artificial object. Is it something coming from the past, like a fossil, or coming from the future? So this type of ambiguity was the aesthetic horizon that we wanted to have in the project and articulate onto the different pieces. And you can see some details here. What will the future look like? Whenever a hotel, motorcycle, dress, trash can, or just about anything else is described as futuristic, it is usually because it is designed in a style that harks back to the 1960s space race. There is another visual stereotype of the future, the dystopian spectacle of chaos and decrepitude portrayed in Andrei Tarkovsky's sci-fi film Solaris, and the succession of movies. But in design terms, this aesthetic is more accurately described as beaten up than futuristic. By contrast, the smooth curves, glossy plastics, and bold splashes of color in the sets of Stanley Kubrick's 2001 Space Odyssey and the TV series The Jetsons have dominated our visual perceptions of the future for over half a century. Not for much longer, we are now assembling a very different vision of the objects and spaces that we will use in years to come. A stream of technological advances, from increasingly sophisticated sensor to developments in 3D printing and other digital production processes, suggest that the future is not what it used to be, at least not when it comes to design. So this quote, which was from an article that was describing by Alice Ralston, was describing the collagen masks and other new products which were coming out in those years. 2013 was a bit the hype of 3D printing. And was quite key for us to understand the fact that the future is not something fixed. The future is something that is designed. And contemporaneity, designers are always designing futures to come. So whenever you do a project, you also cast a vision of how a future can be. And then there is a constant production of this future. So another type of future that into which production we started to engage was, instead of being inspired by the microstructures of shells of crustacean and insects other than fibrous formation, like the images that you're seeing here. So also in this case, we started working with the digital simulation to understand how this type of microstructures of holes and stiffer, more rigid parts can be organized and aggregated onto complex objects, and try to get something like that. So that's a new direction of work which we embarked just after the collagen mask is named Carapace. And the idea is that you can have these shell-like objects that into which a distribution of holes is being controlled digitally, and that distribution allows to control properties of the object, such as transparency, permeability, and weight. Clearly, where the holes are larger, the object is more permeable, is lighter, and you can see through, and the opposite in the other areas, and eventually 3D print these objects as well. So this research, this different type of future is what we named Carapace. And also in this case, we worked initially with a set of masks. And this is the first mask, it's the frontal mask, and it hints an idea of protection. We think while the mask before was talking about symbiosis, this is more an idea of protection. And it relates to the face by covering it, by protecting the eyes and the nose, and allowing people to see through by the modulation of the pattern. The object is also made quite lighter by the fact that it is not completely filled of material, but the holes are actually reducing the amount of material in there. And that's how the research has been articulated into this product. There also the research on the Carapace mask took also different shapes. That's another one that works more on the idea of protection on the sides of the head, how this object can become almost like external bones, something that complements our body in the outside and projecting a different type of evolution of the human body. Again, this object can be seen as a possible evolution of technology, like instead of something which is made of steel and glass, something more organic with this super articulated pattern that relates to the head and the parts of the body in a much more integrated and organic way. So another mask, I begin my talk by showing all the masks because I think they show quite well the direction of research. The superabundance mask is again inspired by fibrous formation. In this case, the difference is that we were interested in looking more at fibers as tissue, not as individual fibers, but how many fibers can come together and create a complex tissue in which you can it doesn't matter anymore the individual fiber, but rather aggregate properties such as directionality, density, overlappings, and structure. So in this case, we work with a different algorithm, which is named shortest walk, that is allowing you to trace the connections onto a grid. And different grids support different type of connection and drawing. And when you get a lot of these elements, you get this very complex type of models. So the idea was to imagine a type of growth again, and how these structures can be 3D printed and to obtain objects in which you really look at them as tissues. So it becomes relevant the fact that there are gradients of density or the changes in the orientation of the object more than the fact that there are individual fibers in specific places. And that's another mask. So here the idea is that of a superabundant growth onto the head. So while the first fibrous mask had an idea of symbiosis, something which is connecting, in which the individual features of the face are still readable, in this case, that the growth is so overwhelming that is covering everything. So I also believe that in this mask, there is also a very architectural concept, is the idea that the head becomes a kind of landscape onto which the post-natural formation grows. So in a way, the body becomes a landscape, and it's almost a landscape design operation onto that. One more mask, the accretion mask. In this case, the idea was to work with simulating processes of material accretion. So like there is a substrate and there is material being put onto that, and the accumulation of this material is creating the morphology. So in this case, the material is composed by units, this type of spheroid elements that coming together create more complex aggregations, and then eventually are proliferated onto the head and creating a different kind of growth and a different kind of relationship. So that's a concept that's pretty fresh 1 month ago, maybe a possible other direction. And understand a completely different relationship. I think this mask is a bit more aggressive, maybe, than the first one, maybe a bit more in the direction of the last one. I can read a conflict between the head and the object, and that's something which may be interesting to explore even further. So the mask, I believe they're showing different types, very speculative, high-level artistic interpretation of the questions which were laid out in the beginning in the discussion of the post-natural. So what is natural, what is artificial, what is human, what is technology, how do these things interact and may potentially evolve in the future to come. My body is an electronic virgin. I incorporate no silicon chips, no retinal or cochlear implants, no pacemaker. I don't even wear glasses, though I do wear clothes, but I'm slowly becoming more and more a cyborg. So are you. For we shall be cyborgs, not in the merely superficial sense of combining flesh and wires, but in the more profound sense of being human technology symbionts, thinking and reasoning systems whose mind and cells are spread across biological brain and non-biological circuitry. So the idea in all our work is the idea of prosthesis. A prosthesis has to be intended as something that extends our body, introducing possibilities for its movement, for its relationship with space, which were not there before the prosthesis. So if much of the work which I've been showing so far has works at an abstract level, like artistic level, now we're going to see how to get into more an actualization of the projects. One way, like one direction of work for us at MOX has always been, since the beginning, working with medical products. That seems to be a quite direct interpretation of the more technical developments which were behind the mask. So the idea is that if a device such as a mask can be customized perfectly onto the body, that may have benefits for products which are customized as well, like the medical ones. So the fact that there is a medical product which is really customized onto your body is something that was seen as a potential. And we were interested in trying to evolve the idea of the medical product from something which is just showing a disability, the fact that we are missing something, to something that can actually be a beautiful object, a fashion product that may actually show a different type of nature or evolution of our body. So the starting point was a leg prosthesis, the one that you're seeing here. So the key idea for design was to relate to the human body in terms of form and volume of the object. So the shape relates with the 3D scan of the healthy leg, but it's also introducing at the same time something different, something more specific and new, which is precisely like the articulation of the joints of the knee and the ankle. So we were interested in creating something that is related to the human body, but being at the same time quite different in order to show a new identity. Another product in which we engaged was the idea of the orthosis. The orthosis is a device which is actually making parts of your body stiff or rigid or controlling the movement of certain part of the body. And for instance, there are certain pathologies in which like your hand needs to stay rigid in a certain position. And we were interested in how to evolve the devices that generally the orthoses are like. They don't have perforation, they come in standard sizes, and generally there is a discrepancy between the individual hand and the size which is being proposed. So an object like that is customized on the individual hand because there is a 3D scan behind it. The perforations are making the object more comfortable, both because air can go through and also water, so the hand can be washed, the sweat can evaporate, and that makes the whole thing more comfortable. But also, whenever you have larger holes, the object is more flexible, and whenever you have smaller holes, the object is more rigid, more stiff. So you can also articulate and control a bit of movement of the object in that way. Otherwise, the object would be completely stiff and a bit less comfortable. And I mean, different people can benefit from different patterns and different ranges of flexibility, and that's what we're seeing with these devices, that there can be variation for that. Another product is another orthosis. This one was for the leg, was based on a 3D scan of the foot. And so also this brings an increased comfort, and the whole design of the piece was geared toward controlling the amount of movement and deformation the object can have. So another product, this is coming straight out from the research on Carapace, is a walking stick. This is the world's first 3D printed walking stick. So I mentioned before with Carapace the idea of the external bone, and in a way the walking stick can be thought as an external bone, so something that helps the body to move and supports it whenever we need and when the body is not enough anymore. So if you are familiar a bit with the morphology of the bone is characterized by the fact that it has a very smooth surface from the outside. The shape is quite organic, but still quite simple, and it is very smooth. But if you cut a section and you see the interior of the bone, then it shows a very complex articulated trabecular structure. So the studies on the bone have shown that the structure is changing in density according to the loads and the stresses that the bone is suffering. So wherever there are the highest stresses, the structure is denser. Whenever the stresses are lower, the structure becomes less dense. So we were inspired by this idea by developing the internal structure of the walking stick to work in a similar way. So the Carapace pattern here was designed in a 3D way and is filling up the whole space inside the walking stick and changing densities according to a structural map that was developed by Arup for the project. So the walking stick this way can offer all the structural support that is needed, but at the same time is making lighter by the fact that there is no more structure than what is actually needed. And so that's the way in which the idea of the bone was transferred to the project. So clearly for this type of structure, you need to 3D print them, and then the object was 3D printed. Another stream of work also introduces some of the projects which I would like to show, which I have been working on as part of the team at ZAHA HADID DESIGN. I was quite lucky there to be able to work on this set of projects here, which is the Future Skin Collection. The idea is that it's a collaboration with Odlo, which is a Swiss company. They are doing sportswear in generally, specifically for winter sports, such as skiing. The idea is that of base layer. So these are thermal garments. It means something to warm you up when you go skiing or when the weather is really cold. And what we wanted to achieve since the beginning was the fact that different parts of your body, while you exercise, may need different type of thermal protection. So certain parts may need to be worn up more and other parts may need to be worn up less. So we started working with 3D maps of this body that were incorporating this information and understanding how to translate this information into the garment to have then an object that doesn't perform the same way everywhere, but its performance changes in different parts. So as you can see from this detailed image, there is a pattern onto the textile. And the pattern is not a printed one, it's a pattern on knitting. So there are 2 or 3 yarns, the different yarns have different colors and thermal behavior. So the idea was to control the way in which these yarns are being knitted together. And then wherever the yarn which is warmer is predominant, that area will be warmer. And then wherever that yarn will be less present, that the area will be cooler. So here you can see a bit more the technical details of that. The images on the left are the body maps that we use. They're given information such as thermal behavior and perspiration and need for structural support. And then you can also see in a different coloring the different details of the pattern onto the garment. So the idea was how you can connect these technical requirements with the distinctive design language of ZAHA HADID Design. And if you know a bit the brand and the type of visual language of ZAHA, it's all about continuity and movement and seamlessness. And also in this case, this is something that we managed to achieve, is the fact that the pattern is continuous, that there are not like distinct separated zones with different thermal behaviors, but rather the behavior changes continuously. So you transition seamlessly with a gradient from areas of a condition of high thermal behavior to areas of low thermal behavior. And here you can see some close-ups of the knitting, how different yarns come together in the structure. And this type of research was also brought forward to activewear for training. So if you look like these garments here, it's not anymore about thermal behavior in terms of knitting together different yarns, but rather how to open perforations into that. So there are tiny holes which are larger whenever the body needs to breathe more, and while instead there are no perforation where there is no need for that. And then, so I think this, I was quite lucky to work on that because as you can see, as we move through the products, we move from the masks, which are very artistic, speculative products, but then we transition also more onto more other objects which are more actualized, more also market-oriented in a way. So I felt quite rewarding for me to explore how the type of research can move from a very abstract, high-level, theoretical inquiry to something which becomes more and more practical, more and more applied, more and more day-to-day in a way. It's also that it's not only a matter of actualization, it's also a matter of how far your vision of the future comes. Certain products are looking at the 50-year-old future, other projects are looking at the 10-year future or 1-year future, 6-month future. So I think it's also interesting for a designer, if you're pursuing a line of research, to try to work at different time scales, and then also pursue different goals in relationship to the time scale that you're hinting at. So moving slightly, changing slightly the focus, as a computational designer, I don't engage only on products that relate to the human body, but also a more general formal concept. So this is an idea of a trophy. Basically, what you can see here, it's an award for an interior design competition, still a project of ZAHA HADID Design. And the idea is that there is a first, a second, and a third prize award, and the three of them come together in a single block. So the idea here was to try to understand how the block is marble, is made in marble, and the idea was to try to understand how to create these three objects. And since there are 10 awards into the competition, how you can apply the same design language to all the 10 awards. So our take was to create a population of objects in which each piece is different, but at the same time, all the objects are answering to the same, are related to the same design language and the same design DNA. So the rules of formation are the same throughout the 10 awards and eventually the 30 different pieces, but the way in which these rules are applied to each of them is changing. So you can see there is the idea of a wave that moves. So each object, each trio is like a different step in that wave. And that was a way to achieve diversity and variation and complexity out of from the same design language. So as I mentioned, eventually the different awards were milled from different marbles. This is a Verde Guatemala marble from Italy. And then there was also Carrara marble, like this one. Nero Marquina marble, which is a different one. So the 10 different awards, each of them have a different type of stone. It was milled, so in the end, the display was having all these marbles together and with the different shapes that we saw before. Another project in which some computational design thinking has been applied, this is a different product, is a product for exhibition. So the idea is that how you can create a landscape of exhibition, in this case was to showcase the products that we designed as ZAHA HADID design. And then so our take was to work on this milled foam objects that also change according to gradients, and by aggregating them, you can create complex morphologies and a complex exhibition space while retaining the same design DNA. So this, I hope, is giving a bit of a clue of what I'm doing at ZAHA HADID design. I'm responsible in many projects for computational design. And then if it's not something that relates directly to the body, I'm interested in the fact that you can think of objects as family of products, and then you can bring variety onto that. So some of the ideas which were lying also at the beginning with the mask, the fact that the objects can be customized onto people. So there is not one object, one size fits all, something which is repeated always identically, but actually objects can vary according to different needs and conditions. And this is something which we're trying to explore in as many different projects as possible. Now we make a leap and then we enter, I want to show you some projects from the work, the research work that we do at UCL de Bartlett. At a very broad theoretical level, what we are interested in is to explore relationship, to explore the potential in design for the relationship between different forms of intelligence, like human intelligence, artificial intelligence, and biological intelligence. This can be seen as another shade of the post-natural idea introduced at the beginning, how different forms of intelligence can coexist and relate to each other, and as such break some of the boundaries between ideas such as natural and artificial, material and immaterial, and so on. So I'm going to show you two lines of work. The first one is named Fisarium Computer. In this case, the research is about working with a mold, which is named Fisarium polycephalum. It's a mold that creates this pattern. So it's basically, the idea is that you lay a set of food sources, and then which are like the center of these circular spots that you see in the image. And the mold is growing by connecting, like spreading its extended body, distributed body onto the experimental ground to connect as much as possible all these nutrients. And then it tends to create optimized connections between them. So how this behavior can be translated at the scale of the city as a model for transportation or for movement, or for translation of patterns onto the city, that's something that we inquired into the studio at the Bartlett by looking at how to simulate digitally the behavior of the slime mold, by working with networks of shortest wall connection, understanding what is the potential of that for design, like which kind of transportation networks can be beneficial, can find benefits into that, or how you can arrange complex movements of people or goods or entities onto the city, and eventually translate also at the material level these patterns onto the city, or exploring them also in complex models, how the the city of the future can be transformed by this type of intelligence and eventually creating complex patterns and conditions. So the idea is that when you create these objects, eventually you realize that the object is created by not only by you as a designer, but also by how you can translate the intelligence of the biological entity, the intelligence of the slime mold onto the city. How the slime mold can become in itself a computational tool similar to the ones that you use to do a digital drawing also, or how the slime mold can influence at some level your design proposal. So that's the kind of research question which is behind these projects. So another one was, again, the idea of how you can use a living entity as a biological computer. And in this case, we work with spiders instead, looking at the way in which the spiders spin their web. So as you can see here, the spider is a type of harmless tarantula. It's within an acrylic box with a 3D printed substrate. And in time, the spider starts to spin its web by relating to the geometrical constraints that it finds around itself. So the geometrical constraints, which are like the 3D printed lattice and the box itself. And as you can see in these images, the spider relates to them. So this type of tubular web which is being formed is formed in relationship to this substrate. So you realize that as a designer, you have the potential to orient the behavior of the spider and to basically not decide what the spider would do, but rather orient the way in which you will create this complex patterns and information. So we were interested to try to speculate on how this can be used in design. And we started doing that by doing some complex models, looking more and more in ways in which the spider spins, how the spinning can be controlled, but also looking at digital drawings that can somehow relate visually to that space. So in a way, like something which relates to the drawings of the superabundance mask, working with a vast collection of fibers, lots of elements orchestrated that you can look at them as tissue, and then you plan the direction, the orientation, the kind of general condition of the tissue, and then see how the tissue behaves in relation to that by working with different densities, different hierarchies of fibers, and starting to get a bit more architectural. So how these fibers can fill up space or relate to architectural constraints, how they can become system for facade, like covering facades of building or covering interior spaces, and articulating complexity in the interiors. So the these fibers also have a very volumetric appearance that we start to investigate as potential in these drawings and models. So eventually, the key assumption was to understand how a design context can be turned into a biological model, and then the biological model can inform a set of digital drawings. So to do that, we work again by creating a base structure for the spider to spin, and then once the spider spins its web, we 3D scan the web itself, which is the cloud point that you see in the middle is the digital 3D scan of the web, and then use that point cloud to orient a set of drawings. So this here we can see some images, some cut sections through the 3D scan of the web, and the relationship between the point cloud of the 3D scanned web and the fibrous formation, how the model can be expanded onto a city. So the idea is that you abstract the model of the city onto a model for the spider to spin, and you 3D scan the web, and then eventually you create a drawing at the city scale. So in a way, it can be argued that a drawing like that, a model like that, is informed by both your own thinking as designer, but also by the intelligence of the spider. So you lay down certain conditions for the spider to spin, the spider spin its web, and then you extract the information and translate it onto the city. So this type of drawings were also had an application in another interesting project that ZAHA did. Architects here I was working with the computational design team before joining the ZAHA HADID design team. It's a projection mapping, so it's a projection onto the castle of Karlsruhe, 10-minute projection mapping. The facade is 180 meters long, and the idea was how to use simulations such as the fibrous one to create complexity and to create entertaining onto that. If you think again of how we define post-natural beginning as an ambiguity between also digital and material, physical and not physical, you see that also like a design such as the projection mapping fits into that category pretty well. So fibers don't need to be necessarily materialized. It can also be something which is just structures of light. Light being projected, and then that can be something that orients choreography, like a spectacle, like in this case, but maybe it's also a way in which the city can be augmented with another layer, which is immaterial, which carries information and is not necessarily built. So also there is an immateriality in architecture, which is explored by this project, which I find very, very fascinating. So the last stream of research which I'm going to present now is the research on eroded formation. I've been fascinated for a very long time by eroded formation in general, by how wind and water and the thermal exposure to the elements can carve complex environment spaces which have an extreme visual richness of patterns at different scales and morphologies, and I was always intrigued by the idea of how to simulate this type of structures digitally and how to create in between something which is post-natural in that sense, a post-natural type of erosion. So I started approaching that type of research with a set of drawings, the one that you see here. These are drawings based on a generative algorithm which is rearranging pixels in images. So the idea is that you rearrange images and create more and more complex formation out of that. So what is interesting for me in these images is that there is a very clear three-dimensionality into them, but at the same time, the object, there is no 3D model for that. So it's a kind of an optical illusion that recalls back to some optical illusion of the classics painting, like the way in which the perspective originally was being used to give an idea of three-dimensionality onto a canvas. And this is a kind of generative perspective in a way. Like there is a generative three-dimensionality which is coming out of how the algorithm works in itself. At the same time, at a more intuitive level, if not that conceptual one, I find it interesting the fact that this makes think of something very material on one hand, something eroded, something corroded, something a process of decay or transformation of matter. But at the same time, there is that element which is that stretched pixel, which is incredibly digital in its appearance. So I feel that this is really a way between material and digital in a way, and that's what fascinates me the most in these drawings. So I started working on a variety of them to try to understand how this post-natural erosion would work and can create complexity, different scenarios. These are abstract images in the end in which this illusionary perspective is being explored together with with investigating patterns which are at the same time natural and artificial in the way they look. When I say that, I mean that if you look at them, you tend to say it's not clear whether you would associate them with the natural world or the artificial world. In a way, I think they retain elements of both, and that's what makes them interesting, I think. So after the initial research on that, I started thinking how to turn in actual 3D models that, because I wanted to progress, I want the object not to stay only as images, but to become sculptures, to become also potentially architecture of a larger scale, or something that engages more with the world, exploring also different type of media than the image itself. One project in which I investigated that is what I call post-natural Cretto. So Cretto is a series of works from an Italian artist from the 1970s, whose name is Alberto Burri, who was interested. I don't know if you guys ever saw like paintings from the Quattrocento, like paintings that have a few centuries on their back. If you look at them in detail, you see that there is always this structure of small creaks and fractures onto the paint itself. So there is a pattern of tiny crispy lines in which the paint starts to break. And the idea of Burri was to explore the potential of that type of fractures in themselves, beyond the painting. So take away that thing which is generally thought of being a defect of the aged painting, just to take away all the figurative part and just make art objects out of that pattern itself. So that was the idea of the Cretto for Burri. I was fascinated by that, but also by how this Cretto have a potential for landscape. I do believe that also if you start scaling them up, that becomes something which makes you think of very complex landscape, and there is something very architectural onto that. So the idea of post-natural Cretto is to try to reload the idea of Cretto and interpreting it with contemporary visual languages, so working with simulation of erosion and trying to understand again what's the relationship between body and scale, body and pattern at this level. So the Cretto which is proposing is a kind of large bas relief piece in which you imagine a fictional landscape and how it would be and how would be the relationship between different parts. The patterns work at very different scales. So there is a pattern at the large scale, but the more you look in, the more you find details, and that makes you wonder how this type of landscape may be and how it would be explored and how it would be characterized. Another concept project is Karst, which is a sculptural piece in which we go back to that idea of the pixel, but as we turn it into a 3D model, it actually becomes something more of a voxel from what we can see here. So the idea was, again, how simple unit voxels can be aggregated according to very complex patterns in a way a bit like as the images that we saw before, that there is this simple unit, the stretch pixel, which is organized according to a complex pattern, makes you think of an eroded body. And this project is a prototype of an architectural element, an artistic installation that goes in that direction. And yeah, and with this slide, I'm bringing it to a closure. And this is my last part of research, the last chapter in my post-natural design research. And I just entered fabrication of these pieces a few days ago. So I'm quite excited, and that's the next to come. Thank you for your attention, and I look forward to your questions.
Thank you so much, Mr. Filippo, for this amazing presentation. Regarding the fact that you have opened our eyes to a completely different scope and completely different field that we didn't even know that existed. And I think thank you so much for also giving us your time and bringing to our attention so many different details. Just a reminder for the people watching, you can ask your questions in the comments on YouTube live. Until we receive the questions, I will ask you a question from myself. So this initiating MOOCs after you graduated, your degree is in architecture. That's correct, right? So after graduating from and obtaining the architectural degree, what initiated you or what inspired you to begin MOOCs and move into the computational design field? Because while you were explaining, you mentioned that I am a computational designer. So you describe yourself as a computational designer or as an architect or both, or you neglect one. So what made you, what was the source of inspiration that led you to this point?
Yeah, so thank you. That's a very good question. Actually, it's two questions in one. So in the terms of definition, I think I work at different levels. Like some projects are projects of a designer, other of an architect, other ones of an artist. Like for me, I don't need to label myself in a specific way. I think I engage. Most of my projects are design projects, but some of them are more in artistic direction. And from my own point of view, I just think the process is the same. It's just different in the brief. Like when you work on different projects, you just pursue different things. Like if a project is more artistic, like the masks, you approach them with the target to speculate, to make people feel feelings when they look at the object that you have. Make people question, open up question, all what I was saying about what's the evolution of man and technology, how our bodies are going to change. So when you work on this project, your brief is how you can address such question with a product and bring forward a discussion. While when I work on a product design like the sportswear collection, then the brief is much more specific. It's about designing a set of sportswear with certain criteria and everything. So for me, it's just registering different briefs and then applying the same method to all of them. But in the way in which I design, like day by day, it doesn't really change from one to the other. Like the process is similar. Like I start from concept, put together a set of references, start sketching, test the sketch against the references, try many variations, and so on and so on. And we can also get deeper into that. But like the process is the same in that sense. So for me, I don't feel the need to define myself completely as one as the other. I do think that when you do a project, you need to have clear in which direction that project is going. Like to think that an art project would do well for architecture or to approach in a very architectural way an art project, I think that is more problematic because it may be confusing. Then the reasons why I started working on MOOCs, like towards the end of my degree, I started working with computational design. I did an internship at Plasma Studio in London before graduating in 2009, and that was quite a key moment for me. Then after graduation, I did another internship, well, that was actually a job in Vienna for 1 year in 2011. Then for a set of personal reasons, I was forced to come back to Bologna, my hometown. And for the type of research that I was doing, there was no job offered. Like there was nothing like that would excite me. There was nothing that I would feel I want to do this thing. So luckily, I was not in the pressure of like I had some time to look around and think what to do. And then I found out that there were a program from the European Union in which you could apply with a research project and get funding for that. So I started thinking, okay, with my knowledge at this point, which type of program can I propose? And I proposed a product on mass customization of of products and 3D printing, and it happened that we won it. I did it together with Alessandro Tomparelli, who, as you've been seeing in the credits, co-founded MOX with me, and we work together, and we still work together on some projects for quite some time. So looking backward, for me, that was quite important, and I think it's also something good to convey to people that sometimes facing obstacles, facing difficulties in getting something, makes you find another way around, which is eventually more productive. Like in retrospect, if I think of that, what I did was eventually much better than just finding a job somewhere, because that led me to explore something new. The project was successful, we were very published, then I received the offer to join ZAHA after a few years. So in retrospect, the fact that it wasn't that easy to get into that immediately, it worked well. But back to your question, everything started because I had to go back to Bologna for some time.
That's a bit more understandable and interesting that you felt like the need that I need to fulfill what's interesting for me, not what my degree says, which something most generally people don't think in this perspective. So it's really interesting. And we have a question from one of our professors in the faculty. It's in Italian. I don't know. I don't know how I'm gonna read this, or I'm trying to.
Copy in the chat, maybe.
Yes, I can copy it to the chat. Yes, there. It's on the chat. You can read it from there.
That's a good question. So just to translate, the question is saying that coming from a country with a strong historical background and a master's degree in one of the most ancient universities in Europe, because Bologna, I guess, if not the most ancient, is one of the most ancient ones. It has like 1,000 years of history. How could I put together that with such a new design technology and vision? So I think that's a very good point. That's a big struggle, which I didn't feel myself, but like within my university was felt a lot. Like lots of people really felt the fact that so we have this historical background, so that's we cannot do new things. It's almost not ethical to do new things. And many people, if you even mention ZAHA HADID, they say it's the worst. So in that sense, that's something that you feel. But at the same time, there is also another face of Italy, I would say, that is very related to innovation and is very forward thinking. Like, for instance, if the black material of the masks that is quite distinctive, that's a 3D printing material of a company that is based in Modena, which is very close to Bologna. And the whole area there, it's very forward thinking because it's related to the car industry. So imagine that within an area of 100 kilometers, we have Ferrari, Lamborghini, Ducati, all the big names of Italian motor industry. So that means that there are also many industrial realities with forward thinking attitude. So like the CEO of this 3D printing company, soon after graduating Modena, went to work for a few years in the States, developed his technology, then came back and put together the company. And I mean, the material, we use them for do some masks, but they use their material like to send satellites into space, or Formula One cars use it for certain parts and everything. So Italians have this double nature. Like there are some realities which is very ahead in terms of innovation and design. Like for myself, I think that probably when I was there, I've been always fascinated by historical references. Like I do like it. I like when I'm there. I like to go around. I have many references in mind, but I have to say that when I work, I'm definitely more on the future side of the thing. So I guess that for different Italians, you can get very different balances. If I were to work in Italy, I would probably have to face more obstacles. Now in London, the mentality is the way people think is much more forward thinking, especially in a place like ZAHA Hadid or the Bartlett. So that's easier to look ahead for that. But that's a good question, and something that can be discussed even further.
Also, regarding your interest in the future, as you mentioned in this answer, that you would rather look to the future within the design scope. Also, another professor from our faculty has asked, we see that the connection between your designs and natural created things are very close to each other. As you have presented at the beginning of the presentation regarding the Cambodia these structures and all. The question is, if we design only based on our nature, can we create better world, or it would be delusionary? What do you suggest for future designers? What awaits us?
That's a good point. Like, I think it's actually, I'm interested in something which is neither openly optimistic or pessimistic. Like, I think I'm interested, and that's what I would suggest to designers, to, when you design, try to create scenarios which are complex, in which you can see many things going on, and these things are not necessarily utopic or dystopic, because I think that's a bit more real. Like, I think it becomes valuable when your design is able to describe possible dynamics to come, possible transformation to come. Then I think that seeing already things in terms of black or white is a bit too fast. I think I'm more interested in the grayscale, or the fact that there can be both blacks and white in the picture, to use an analogy. So also back to the thing of looking at the future, one thing which is super interesting for me about the futures is that, in fact, when you work by crafting futures, that's more than predicting the future. That's a way to think about our contemporaneity. So generally, your action of crafting a future is more like projecting contemporary elements onto the future. So eventually it becomes just a way to rethink of our contemporary world. Now, none of these objects wants to be an actual predictions of things to come, but rather to imagine possibilities and also to highlight trends of thinking in contemporaneity.
There is also a question almost similar to this question. Since you've mentioned that it rather not being black or white, it would be better to bring them together. Would you rather have this design language be dominant for future work, or dominant within the world? Would you think if this kind of design language would work all around the world, would it be better, or?
No, I believe in plurality. I think that I hope the future will be plural, in which many things are there. Like, I hope that this design language may grow a bit more and expand a bit more, but I really like when you see different things. Like, when I look at the city, for instance, I'm very fascinated by the city in which you can see more diversity around. The fact that the buildings are different one from the other. It's also a bit like yeah, I like the fact that that's one thing which I like about London is also that reflected in the building and the people is that there is many diverse things going on. So if I am to express some hopes for the future, I hope in the future with many different design languages, because that would also reflect different human aspirations, and I think there is space for all.
There are actually several questions over here. So there is this interesting one. It says there's an element of darkness and romanticism in some of your design research. You transmit emotions through your art, or is it purely technical?
Yeah, there is an element of darkness. Romanticism, I don't know, but there are feelings that do emerge. Yeah, I mean, some projects like the more artistic one, I think they are meant to create feelings, like, and feelings not necessarily with the capital F, but like they're meant to provide some intuitive understanding of what you're seeing. Like you look at that and there is something that comes to your emotional sphere rather than logical sphere. In that sense, I do have a taste that tends towards a condition of darkness, unsettlement, and everything. But I also think that there is also another element that generally you perceive something as dark or unsettling when it's new also. So I like the feeling that you are unsettled in looking at something because it also means that it's something new that you're not used to. So I think that a radical innovation must produce uncomfort. If it's something, you look at something that is too comfortable, it means that it's not radical enough, it's not new enough, it's not something new, it's something that you're used to. Anything brand new, really new, provokes a feeling of discomfort. And that's something which I like. I think if people were to see my work and find it too bright, too comfortable, then it would also mean that wouldn't be that innovative in that sense.
Also, within your these research products that we have seen through this lecture, you have discussed that each product is customized and designed. It's not necessarily that a product is going to be placed for everybody. It can be customized according to the usage of the person or whatever the reason for this product is. Most of these characteristics like permeability and durability, how are these defined within the design scope?
It depends. Now, I mean, yes, most of the products are customized.
I'm sorry to interrupt you. Also, since these characteristics are shown with like whenever there are certain organic forms within the design, like the openings of the circles or the shapes, or generally within the product itself. Yani, how do you determine? Do the characteristics determine the size of these little elements, or?
So generally, okay, I understand that. Generally, we do not have such a specific brief on those research products because people generally don't know exactly what we can do and everything. So when we started working on the generative orthosis, we did not have at the beginning like a specific brief that needs to be porosity and everything and so on. We just started working. We say, okay, there are a few things that we can do. Let's try this, let's try that. And we also tried a few things which are not in the presentation, of course. And then eventually you develop something that may work. And then there you see what you can do. So generally like the specification for like size of the holes and something are something which is defined later in the process by a number of factors, like what looks good and what doesn't look good, what which are the technical limitation of like the technology that you're using, like with 3D printing. I mean, the holes cannot be any size. You can have just a certain set of sizes that you can work with as the thickness of the object and everything. So generally, some things are defined, like you have an idea of which are the products on the market. You know what works and what doesn't work. The key idea was there from the beginning. Like when we started working with the orthosis, the key idea was to just make something customized onto the hand with the 3D scan. But then as we work on it, we also started seeing other potentials. So that's something that happens often in research project, that you start with a loose brief and the brief becomes more specific as you go ahead, and you also participate in crafting the brief. The client doesn't have, as you don't have at the beginning, no one at the beginning has the overview of what is going to come out of that.
Also, we have two more questions left. First, the programs that you use for these computational designs, as a person who is still learning in the beginning, which programs do you recommend? And then the programs that end up for the final results, are they one program usage or several ones?
Yeah, so there are a few questions here. So the programs that we used a variety. Like at the beginning, we were working quite a bit with processing, like scripting stuff. Then we tend to move at MOX. Then Alessandro works a lot with Blender. I work much more in Rhino, Grasshopper, and Maya. Then at ZAHA, you use only Rhino, Grasshopper, and Maya. That's the standard pipeline that is being used. In the last thing with the erosion, I started working in Houdini also. And at times I also use other tools. So that's just to say that at the moment, I mean, all this one, processing, Blender, Maya, Rhino, Grasshopper, are software that we may use or we may not use in combination. Like if you're into computational design, when you start having like 10 years of experience, you know many softwares, and you just do bits of things in different softwares, whatever works better. It's also easy when you have a bit of experience to get started on new things. So for me, like, not only for me, like for people which are a bit experienced, like doing something new in a new software is not something that complicated. You generally do it if you see a potential. To begin, I would say it depends on a number of things. I think it depends a lot on which type of project you want to do also, which type of direction you want to take. And in that sense, there may be very different entry points. Like, I don't know, but like if you are to work in architecture rather than product design, if you already have a clear idea, that's already different as an approach. I think maybe a conversation should become a bit more specific. When there are a few things which are changing, like when I started, there was a lot of focus on the pure scripting, like processing, writing code on yourself and everything. I think that now there is a lot more which is packaged in a way, like with software like Grasshopper, which are node editors, or Houdini, which has a node editor as well. So there may be easier entry points for that. I mean, I as a very general indication, the platform I use in the most is Rhino Grasshopper. I think that if you do architecture, that's the one in which there is the most. And then that's also what makes you more flexible, I guess, in general. But then I don't know, maybe it also depends on what you want to do.
Well, within your answer, you answered the question coming up already. So we would like to thank you again very, very much for coming here and making this incredible lecture for us. and bringing to our attention many, many different scopes from things we could never have thought about. Thank you so much. Now we're gonna end the YouTube live. So on the chats, everybody is thanking you from our faculties and our students. Thank you again.
Thank you a lot, everyone.
I think the live has ended.